Hello, I'm Alex Hansen, and this is a quick tutorial on using Excel to run a paired sample t-test for the Colorado State University Prevention Research Center's Outcome Evaluations e-course. You can find this no-cost online course along with the example data we use in this video and other prevention resources linked. At this stage, we have already exported our participants' data from our data collection software, whether that be Qualtrics, Google Forms, or otherwise. We have made a copy of our dataset to match participants and remove matchless participants from the newest copy of our dataset using their unique IDs. We've shifted the matched data into horizontal format to more easily compare participant pretest and post-test scores. We have cleaned and recoded the data to be numerical. We have calculated participants' total scores on each of the scales for both of their pre-test and their post-tests. Which we then use to assess mean change and percent change by averaging all the participants' pre- and post-test scores, then assessing the difference between their pre- and post-test scores. Now that we have our pre-test scores and our post-test scores prepared, it's time to generate the paired samples t-test to compare those pre- and post-test scores. So you'll want to go up to the ribbon at the very top. Up here, there should be a data tab. If you can't find this, you may need to turn it on by going to File and then under Options, and then going to Customize Ribbon. It should be checkmarked here. And if it's not, you'll want to checkmark it and then click OK. You may also need to go to your add-ins and make sure the Analysis Tool Pack is downloaded. All right, now we should have our Data tab available as well as our Analysis Tool Pack prepared. On the far right here, we can now see Analysis. We're going to click on Data Analysis. We're going to scroll down to t-test, paired to sample for means, hit OK. And then we're going to insert our variable 1 and 2 ranges, which variable 1 is going to be our pretest scores for all the participants, and variable 2 range will be post-test scores for all our participants. And I have not included the labels here, so I'm going to unclick the labels button. We're going to keep our 0.05 alpha. We're going to add an output range. I've decided to put it in the same spot as our example data here. And then we're going to hit OK. All right, so now we have the t-test output, and I've gone ahead and highlighted a few important areas. So you'll see here we have the mean score for the pretest and for the post-test respectively. You'll see that there's 16 observations in each, which means that we highlighted correctly before. And most importantly, we see that the p-value of this two-tailed test was 0.11, which is higher than the 0.05 mark for the alpha, which means that our results are not statistically significant this time around. That being said, it is still worthy of looking into the effect size to kind of get a little bit more of an interpretation of the practical significance of this data set. All right, so in order to calculate the effect size, what we're going to need to do is we're going to first calculate the standard deviations for the pretest and the post-test. So what we're going to do is we're going to write in the formula equals standard deviation dot p, that's stdev dot p, and then parenthesis and put in our first our pretest range, hit enter, and then we're going to do the same thing for our post-test range. Hit enter again. All right. Now that we have the standard deviations for the pretest and the posttest, we're going to calculate the pooled standard deviation. And this is going to use a formula that I've also listed above in the example data. So that'll be equals square root of the pre standard deviation. So that's going to be up here to the second power plus the post standard deviation to the second power divided by 2. Close parenthesis. Now that we have the pooled standard deviation, we can go ahead and calculate the effect size. So the effect size is calculated using the mean change divided by the pooled standard deviation. The mean change difference is going to be calculated using the average score of our post-test minus the average score of our pretest. So we're going to use that divided by the pooled. In this case, it looks like we've got a negative 0.68 effect size. So this tells us that there was a moderate to large decrease in our outcome variable, which in this case was from the mood and feelings questionnaire, which measures depressive symptoms. The results were not statistically significant. But because statistical significance depends a lot on the sample size, the number of participants, or the N, there is a chance that gaining more participants may improve the accuracy of this test.